All right, this is the Iodine Clock Reaction Lab, and here are the components. So we're going to do the same reaction at 3 different temperatures. One at the ice bath temperature, one at room temperature, and then this one we're going to be doing in the water bath. And there's a rack in there, so that's why we're using a test tube for this one. We're going to put the same components into each of these 3, and then we're going to start the reaction with the hydrogen peroxide that goes in last. So the components, or the solutions we're going to be using for each of these, 5 mils of each. This is going to be the acetic acid acetate buffer, the acetic acid, the starch solution, the sodium thiosulfate, and the potassium iodide. 5 mils of each go in here, 5 mils of each go in here, and then 5 mils of each go in here. When that's all set, we're going to cool this one down in the ice bath, well, this one's ready to go, and then this one we're going to heat up in the water bath. Then we're going to add 5 mils of hydrogen peroxide to this graduated cylinder. We're going to make sure that I flag it so that we know which one is which, because we don't want to mix them up, because the hydrogen peroxide gets the reaction going. So 5 mils will go into the room temperature one first. We'll do that one first. And it's going to look like water, and then after a while it's going to react and it's going to change color. And it's called a clock reaction because it's an immediate color change, very, very quick anyway. And if you put the same amount of components in each time, the color change happens at the same time. So you can set a clock by it if you do it well enough. We're only going to do 1 run of each, but we're going to keep track of the time with our timer here, and we're going to see how the temperature change affects how fast that color change comes into view. Now each of the pieces of glassware has 5 mils of each of the 5 solutions. The only thing that's not in there is the hydrogen peroxide. We look at the liquids there, you can see they're colorless. And once we add in the hydrogen peroxide, they will change color over a certain amount of time. So I'm going to put each of these, well, I'm going to put this flask into the ice bath, and then this test tube into the water bath. So let's do that next. All right, and sorry if the video is shaky, but I'm not sure how else to do this. Got to be moving all over the lab here. So here's the ice bath. There we go. So that's going to sit there for about 15 minutes just to make sure that it's as cold as it can get. It should be close to 0 degrees Celsius. Here's the water bath. You can see on the screen that it's 40 degrees Celsius exactly. That's good. Sometimes it's a little low. Okay, you can see we have plenty of room for lots of test tubes, but there's only going to be one in there today. Let's put that in here. And the water is high enough to cover up to be high enough to be above where the water line is, the solution line is in the test tube. So we're going to let that sit in there for about 15 minutes and should get close to 40 degrees Celsius. We're going to check this temperature and the water bath temperature with a thermometer later on. So we're ready to go. We have the stopwatch there. I just have some things holding it up, so don't worry about it. Those aren't important for the experiment, but I want you to be able to see the stopwatch. Okay, so I'm going to add in the hydrogen peroxide, press the start button according to the lab, the way I said it should be done, swirl it around, and then we'll see if the color comes in. Hopefully it does. So here we go. Hydrogen peroxide goes in. Start. Swirl it around, make sure it gets nice and mixed. That's what I tend to overdo because I have no idea. You can't tell if anything's happening if you're mixing. You have to assume it's mixing thoroughly. But that's got to be good. All right, now we'll stop and wait. And hopefully you can see that the clock looks like you can see it all right. And then we wait. And this will give us a good idea. What we would expect is that the reaction for the warm water goes faster, and then for the cold water goes, for the ice bath, it goes slower. let's see. And it all depends on how concentrated that hydrogen peroxide was. If it's older, it could take longer. The fresher stuff usually goes faster. So yeah, there's really no way to know until you see it for the first time. Okay. There we go. I'm gonna stop. Now I have it on video so you can stop it yourself. I overdid it. It's probably like 1:30. But yeah, I was gonna say I was getting as impatient as the students are. The first time they're saying, "Well, what's supposed to happen?" Then all of a sudden it happens. Oh, cool. Okay, so that was very quick. It really shifted in a matter of a second or two. So you can double back to where you saw it in the video, what this said when it just began. And you can do it either when the color begins or when the color ends, where the color fully comes in, either way. So that's it for the room temperature one. So you can see what's going to happen. And let's see what happens for the other two temperatures. All right, now we have to take the temperature. I forgot about that. So let's, it doesn't really warm up during the reaction, but I let it get back to room temperature in case it went up a little bit. Here is the temperature, so you should indicate that. And I went back and looked at the video, and the color change was at 1 minute and 30 seconds. You don't have to put the hundredths. All right, this time I'm taking the temperature first. This is for the water bath. Just a little bit over 39. All right, so this is the water bath one at 40 degrees Celsius. And I put up a white screen there to help you see the color change. So it's a little awkward here, but I'm going to put in the hydrogen peroxide. And then once I've done that, I'm going to start the timer. I'm just going to hold it in my hand. I'll show it later. Okay, this one probably will go pretty fast, so I want to do this quickly. And hold this up, stir it best we can. It's at 14 seconds. Seconds. And it should stay warm. You might wonder, is it going to stay same temperature? Yeah, it's going to cool a little bit. Oh, there we go. Boom. 30 seconds. From the time it started. Oh, so you can see faster. The reason that it started low and then it kind of swirled up is because it's such a narrow tube. It takes a while to make its way up, but from when it started to go, that was about 30 seconds. Here's the ice bath. See, it's a little bit above zero. You might not know what you're looking at. I'm going in from above. I had to get a little creative we need to keep this in the ice bath. This one is going to take longer, most likely. So we can't have it out of the water bath too long. I put a piece of white paper underneath the container. And let me get it centered. So I'm going to put in the hydrogen peroxide. Oh, let me get the stopwatch. And here we go. Okay, start. Okay, and then just take it out and swirl it around a bit. I know I got a strange point. Let me get it really mixed up good. Okay, set it in. The room temperature one took about 1:30. And this has melted so much that you can see it's kind of shifting around. I gotta be careful. You don't want it to dump over. That's happened before. Students are never pleased by that. We're at 1 minute and 6 seconds. Whoops, it's kind of tipping. Yeah. There we go. So we're 1:40, so we're 10 seconds longer than the room temperature reaction. And there it goes. And that is at 7 minutes and 53 seconds. So I no doubt will have cut away a lot of that. You didn't have to sit through the 8 minutes. And now that I'm thinking about it, it's been a long time since we did this lab because of how things have been going. But I do remember that 8 minutes is a fairly common one. And so, yep, that makes sense. And you can see that now it took a while, but it is definitely the same color as the other two solutions. And that is your data point. So 7 minutes and 53 seconds.